Welcome guys. So this video will prove interesting theorem. Basically, I find which is so interesting because I never think this type of results. Okay, so basically, this is the harmonic series Hn. So what we know is that from the calculus we know that that this Hn will blows up to infinity. So that means Hn can be arbitrarily larger. But however, if n is larger than 1, then 1 over k from 1 to n cannot be integer. Cannot be integer. So it's obvious that if you take two of them, you get 1.5. If you get this, then you will get 11. So it's very interesting that even though you sum over how you have infinite terms, but none of them will be integer. None of them will be integer. Okay. So this is very interesting theorem. Basically, so the key point is that in this the key point of this video is we want to prove this fact. Okay, so we want to prove Hn. Okay, so if n is non-zero, Hn. Okay, it's not an integer. Okay, basically we already know it's not integer larger than 1. Okay, so the proof is very astonishing that. Okay, so how about we try a smaller case? Suppose we try n equals to 8. So we have this. Okay, so how about we assume that this is an integer? So we assume. So we try a simple case and see whether we can get some understanding. Okay, so key point is that if we times 8, we have 8 times n equals 4 plus. We have 8 plus 4 plus 2 plus 1 and plus 8 times this. Okay, so 8 just okay, so also this. Okay. So if you times 8, then you can these 4 terms can be collected, and the rest of 4. Okay, so from this, what we tell is that a minus a something is equal to a times this. Minus 8 plus 4 plus 2 plus 1. So this is an integer. Not just integer, right? This is a even number. Even number. Okay, so what we have is some things, which is somebody tell that this is an even number. Okay. Okay, so this is an even number. Okay. So basically, you will have am minus 8 minus 4 minus 2 minus 1. Oh, sorry, it's not even number. It's an odd number because you have this minus 1. Okay, so what you have is this. What we have is some odd number divided by 8, which is this one. Okay. Actually, okay. So the key point is that is this possible that this something can be some odd divided by 8? Okay, so the result is if I compute with something, and then this is if you do the final GCD, but basically this come out a multiple of these numbers. All of these numbers are odd, so you will have some odd. Okay, so the key point is that if this is true, then what you have is the odd number times odd number equals to 8 times something, which give you contradiction. Because this is odd number, right? And this has 8. So, contradiction. Okay, so from this small object, give us the hint to prove this fact. Give us a hint to prove this fact. Okay, so we can start to prove. Okay, so the proof is that Suppose we have this up to n, right? So I can choose 2 to the m, which is less than n, but 2 to m plus 1, which is larger than n. So I can choose n, which is close, which choose 2 to n power, which is close to this n. So from the previous examples, we choose 8. Okay, so we have 2 to m, and this is called x. So suppose x is an integer, then we just times 2 to the m. Okay. Okay, so what we have is the 2 to m times 2 to m minus 1 times 2 to n divided by 3 times 2 to m divided by 4 to 2 to m divided by n. Okay, so the fact is that I only collect I only collect the object which is divisible, which is I take all the power of 2 to the left. Okay, I take all the power of 2, so I have to this one plus this one plus this one plus this one. Okay, and the rest is all the things which does not contain power of 2. That does not contain which is not exactly 2 to m. So basically we have this. Okay, so but fortunately is okay. So this is an odd number. Okay, so we have odd number divided by 2m equals to something. Okay, so equals to this one. So by the way, this 2 to the m, which is this 6 contains 2 times 3. So this will be 2 to m minus 1 divided by 3. Okay, and keep going. And then when you go to the 2 to the m divided by 10, you can write it as this. Okay, so you can see that since I already take the largest 2 power. So rest of this sum only contains a lot of rational numbers, but q must be odd. So I can write this sum of p and qn, but we know that qn must be odd. Okay, and then if you take all the list comma multiplier of all this odd number and do the calculation, then you will get something which is odd. So you have odd divided by 2 to 2m equal to something divided by odd. So this gives you a contradiction. Okay, so this is our proof, which I find is really interesting, and we never use some higher number theory technique, but we can still prove this interesting fact. Okay, so I believe you guys like this kind of video, and be sure to subscribe to my channel. I will see you guys in the next video.